What's going on, everybody, and welcome to a Cython introduction tutorial. We've got a lot of things to cover. I'm going to try to get everything fit into one single video, so let's get to it. So first of all, what is Cython? Cython is a superset of the Python language, so what this basically means is it's going to act as a bridge between Python and C/C++. And this means we can go both ways. We can go from Python to C, C++, or C++ back to Python. And a lot of times we're going to do this all in one fell swoop. Now, the glory of Cython is you can do this without really knowing anything about C, C++. It's just going to generate that code for you. Now, why would you want to do this? Well, there's quite a few reasons. Like, there's some kind of objects and like classes and attributes, stuff like that, that are just going to be more beneficial if we did it in C. But actually, some of the main gains you're going to see are just from typing information, and that's it. So chances are, if you've been programming Python long enough and you've been doing things in Python, you might have heard something like I've heard, where it's like, hey, syntax, why are you using Python for machine learning when you could use C or C++ and it would be so much faster? Well, that's because I'm actually not just using Python. I'm using Python, and which is just so happens to be wrapping C or C++, right? That's what we do. So a lot of libraries are actually C-optimized libraries, like NumPy, Pandas. These are C-optimized libraries. They just happen to have basically a Python API for you. So in most cases, you can actually find an already made C-optimized library for whatever you're trying to do, but many times you can't, or at least sometimes you can't. So one way that you can still improve the speed of your Python program is to use something like Cython. So the main thing that, at least at the very basic level, that you can very simply do with Cython, there's a lot of really advanced stuff that you can do with Cython as well, but the basic thing that you can do is just add typing information. So Python is a dynamically typed programming language. What that means is when you type in a variable, you just say x equals 5, but later on x could equal Gary, and you're not going to have any, at least you're not going to have any super errors relating to, at one point it was an integer and now it's a string. You might have other errors in your code because of that, but because it's a dynamically typed language, the variable, we don't have to actually tell the programming language, hey, this is going to be an integer, or this is going to be a float. The problem is, every time that variable is referenced, Python has to say, oh, wait, hold on a second. Let's see, is this an int? Is this a float, string? No. Okay, here it is. Yeah, it's definitely a string, right? This takes time. Now, if you're only doing this once or something in a whole program, you don't really have to add typing information, but when you start to scale out the usage of variables, either in for loops, or maybe you're just a very large website that has a ton of traffic, and you're scaling just in that way, adding typing information can help you so much. So that's what we're going to be showing here. So anyways, to get Cython, what you're going to need is, first of all, you're going to need to... Why are you doing this to me right now? There we go. So pip install, or pip3 install Cython. Now, I already have it, although this might try to put it to Python 2. Yeah. Anyway, pip install Cython. This is actually a Python 3 tutorial, so actually I would do pip3 install Cython. Anyway, yeah, I already have it. The other thing you need is a compiler, or a C compiler. So if you're on Linux, you already have one. Yay, GCC should be already here. If you're on Mac, it should be like Apple's Xcode, I think you can grab, and that has GCC. I don't know much about Mac, so if you're on a Mac and that doesn't work for you, sorry. Go to Cython's website, though, and they have like a bunch of blurbs on there. If you're on Windows, you can use MinGW. That's probably the easiest one to use, but it's still a pain in the butt. That's why I'm filming this on Ubuntu. So anyway, but yeah, it can be done. It's just a massive pain. So anyway, once you have Cython, once you have a compiler, you're ready to rumble. So what I'm going to go ahead and do is make a new folder. I'm going to call it Cython Tutorials, and we're going to go ahead, go on in there. And the first thing that we're going to do is, let's do a new document, example underscore py.py. And let me just open this. So what I mean by like static and dynamic type variables is, like in Python you can say x equals 5, right? But in other languages you might have like int x equals 5. Now what Cython's going to expect of us is either cdef int x equals whatever or not, or it can be like cpdef int x equals 5, something like that. Now I'll talk a little bit more about those when we get there, but that's kind of what it is. Like, so this is dynamic, right? X actually doesn't have to be an integer. Like later on, like I was saying before, we could say x is actually Gary. Screw this autocomplete. Anyway, cool. So now let's go ahead and example pi. Let's do define test. Test will take one parameter, that'll be x, and then what we're going to say is y equals 0 for now. And then we're going to say for I in range of x, don't forget your colon, y plus equals I, and then we're going to return y. We also could say y plus equal, never mind. Anyway, that's good enough. We'll go ahead and save that. And that's our regular Python program. Now, what if we wanted to compile this with Cython? We haven't added any typing information or anything like that, but anytime we do that, we have to compile it to Cython. So first, let me show you just how simple it is to compile to Cython. So, and create like a shared object and all that. So first, let's go ahead and go to File, Save As, Example, Sci.pyx. So .pyx. That's it. Save it. Done. So now what we need to do is create the setup.py. So let's go ahead and new document. Setup.py. Let's open that in Sublime. And now what we're going to do is from distutils.core import setup. Just like a typical setup.py, and then what we're going to say is from cython.build, that's capital C, capital B, import cythonize. Not typical. So now what we're going to say is setup, and then the extension modules that we're going to be using, ext_modules, is equal to cythonize, and then whatever our actual pyx file is, so that's going to be example sci.pyx. And that's it for the setup.py. So really, there's other things we can pass in here, but just for super simple purposes, this is really it. That's all you got to do. So now, all we have to do is actually run this. So we'll open in terminal, bring this over here. Can I do this? No. Can I do this? No. I'd like to zoom in. I know there's a command for it. Sorry. Anyway, hopefully this is simple enough anyway. So Python 3 setup.py build_ext -- in place. I really wish I could make that bigger. You can go ahead and run that. Let's see if I can. Oops, I clicked the wrong thing. Zoom in. Control plus. I tried Control plus. It must be because I'm in a virtual machine. Cool. Anyway, we'll run that. Looks great. Bunch of stuff we don't understand, but that's okay. The thing that we care about is right here. So it's this this SO, this shared object. So what it's created for us is our C file, some build information in here, but we don't really worry about that. But actually what we care about is right here, this actual example sci. Now what we could do now is new folder. I'm going to call this step for deprecated, and then I'm going to take example sci. I'm going to toss it in dep. I didn't mean to go into dep as well. Anyway, now what we can do is we can go and do new document, testing.py. Wow, got a little excited there. Anyway, and now what we can do is we can import example_sci. Now again, I moved example sci.pyx just so you can see that it doesn't import that file. But it won't, if you had that file locally, it's still not going to import it. Like .pyx is not going to get imported. I hope I'm not mistaken on that, but pretty sure I'm right. example_sci.test5. So we'll save that, we'll come over here, and Python 3 testing.py. Does it not? Oh, it won't print it. That doesn't matter. Anyway, it ran. That's all that matters. I don't want to print it out right now. We'll get to some more output information later. Anyway, that's how simple it is to at least build and all that with Cython. right? So now all we have to do is add typing information, and you don't have to, you can add as much or as little typing information as you want, okay? So it's really up to you how deep down the rabbit hole of Cython you want to go. So let's start slowly going down the hole. Now, I've put the declarations, in fact, I think I'm just going to pull it up, because I don't really feel like, let's see, that way I don't have to type them all out. You can go to pythonprogramming.net to get all of these as well, but I'll just pull this over. Cool. So these are just your declarations. So if you've got integers, hopefully you can see that well. Let me go, here we go. So if you have an integer, you can, it's just cdef int, characters, char, float, double, right, single precision, double precision, list, dict, objects, okay? And then you've got def, cdef, and cpdef for like your actual functions. Def is just a regular Python function. It's in Python only, can't be referenced in C. You've got cdef, this is a pure C function, and then you've got cpdef, which is C and Python, so it goes both ways. So a common question is, you know, since basically, because what cpdef's going to do is also generate a way to do it in Python for you. Whereas cdef is only in Cython, so you could only reference that internally. You wouldn't be able to reference that in any of your Python. So then some people might ask, like, okay, why don't we always just use cpdef, right? Well, there might be some things of C that you just can't do in Python, so you have to do cdef, okay? So it's there if you need it. I've never done anything because I don't know enough about C. I've never done anything that I needed to use cdef. I've just always used cpdef. But if you're like real talented in C and you know a lot of tricks to the trade, cdef you might use it, but not me. So anyway, there's that. So so those are the various declarations that we can use. So now what we can do is go back to example sci.pyx, and what are all the things that we can do here? So one thing that we can do is like x. We know x is going, or we're gonna enforce that x is going to be int, right? So int x. So in the parameters, you don't have to do cdef, cpdef. You don't have to do anything like that. Really, you're doing it right here. So def in this case is going to just simply be a Python function, but we can make it cpdef if we want to. We can also specify what the return is going to be. In our case, it's going to be an int. So this is kind of confusing. So normally, I wouldn't necessarily cover that immediately. So first we'll leave this alone. Let's just give typing information to x. But that's possible, and hopefully by the end I'll come back and throw that in there. But then we're going to come down here, y. So y again is just going to be an int. So we're going to do we're going to say cdef y because so I guess I'll just go ahead and contradict myself. But there's really no reason to. We won't ever need to access y again, so we can just use cdef here. So I guess probably the way I should have said it is my functions, like the actual functions up here, I would never use most likely cdef. I don't think I've ever actually defined a whole function as cdef. But anyway, that's what I was thinking when I was going through it. I'm sorry. Anyway, cdef y because we're not going to access y anywhere but this function. Also I. So this can get kind of tricky, but you want to pay attention to really all of the variables. So in this case, I is a variable, and believe it or not, Python's going to ask every single time we hit this I var, and here as well, what's the type of I? Well, we can help it, and we can say cdef int I, and we forgot to give int to y over here. So anyway, I was too busy explaining why I just contradicted myself. So cdef int I, and we don't have to give it a starting value. There's no point. So there's that. Then you've got I's already been defined, X has already been, or rather, I already has a type, X already has a type, Y already has a type, I has a type, Y has a type. Now that we're at the end though, Y is actually the return. So instead what I'm going to say is cpdef int, because we return an int. So int is like, what's the value of the function? So that's why you've got int coming up here, because this function is returning an int, kind of like this variable, right, is an int. So right before the function name, you give what it's going to return. You don't have to do this, by the way. We could just use def. It would be totally fine. Anyway, cpdef int test int x. Yeah, I think this is all good. So we can save that, and we really just need to run setup.py again. Hopefully we'll get away with that. Yes. And then we can test it again. Okay, but that's relatively not exciting right now. So what we're going to do now is come back over to testing. And let's go ahead and let's import timeit. And we'll say sci equals timeit. And we're going to run, I think we can do just one line. So we're going to say example underscore, what was it, sci dot, or example sci dot test. Let's say 5. And then this needs a setup. So we'll say setup equals, and this will be import example sci. Kind of running off the screen. Hopefully I can get this to fit. Cool. And then we're going to say pi. Oh, we need one more variable here. Let's do number equals 100. And then what we're going to do is let's go ahead and take this line, copy, paste. We're going to call this now pi and example pi, import example underscore pi. Cool. All right, so those are the values. So then let's print sci comma pi for the times. So basically what this does, if you don't know what timeit does, I do have a tutorial on that. You can go pythonprogram.net, search timeit, and you'll get a brief tutorial on it. It just times how long these take to go, and you can do like whole chunks of them. Setup, we'll just import it first so we don't calculate how long did the import take. And it's just a really handy thing to actually time operations, because these operations are really, really fast, and tiny changes in what's going on just in the background on your computer can seriously affect if you just use like import time to time these operations. And probably number 100 is too low as well. But anyway, let's just test it. So print, and let's say Cython is, and it'll be some variable, x faster. And then we'll say dot format, what's pi out of sci. So let's do pi divided by, yeah, basically how many times does Cython go into Python? Sorry, my brain is, I think that's right. Anyway, now, so now what we're going to go ahead and do is just run this in the terminal. So come over here, and now let's run python3 testing.py. Timeit. Oh, let's go over here. Where did we say? Oh, right here. Timeit. Try again. Cool. So in this case, we can, I mean, this is a little hard to read, but we've got the multiplier here, and so we see Cython is actually 8 times faster. Let's run it one more time, because this can still vary. Yeah, 12 times faster now, 8 times. Right. So because let's go ahead and let's do like 1,000, maybe 10,000. Hopefully we can run that pretty quickly. Oh my god, it's still a huge variance. Okay, somewhere between 5 and 15 times faster. Anyway, bottom line is it's clearly faster. Like, we haven't actually been slower. So that's not too bad. Now, what I'd like to do is try to drive home why is it faster though. So coming back to here. Where is the largest gain being made? So, for example, what if we said, you know, what if we didn't do this? Like, what if we just got rid of I here. And just remove that, save. And then now let's just rebuild, retest, and then, that's not much faster. Now it's actually slower. Whoops. Oh, shoot, what did I do? I think I just rebuilt it. There we go. Anyway, slower, a little faster, slower, slower, right? So just that line made a huge difference, right? What if, okay, so clearly int I matters. What about, I'm pretty sure commenting should work. Yeah, there's no reason why that wouldn't work, but I'm just going to delete it anyways. Let's rebuild. Test it again. Oh, exception. Why reference before assignment? Oh, yeah. What a noob. Try again. There we go. So, so now it's like 3, 4, 9, 3, 4, 4, 4, 4. Okay, so clearly that one also matters, right? That made a big difference. Okay. Trying to think of what else we could do. We could take away the typing information for X. Now this should be checked only once, right? It'll go through a range, but it should only be checked once. So I'm going to wager that's not going to have a huge impact, but let's see. So we can build, let's test, right? Test, right? Not a big impact because it was only referenced one time, okay? I think we're all set on all the other variables at this point. So that wasn't really truly necessary. So what I'm trying to point to, though, is that the huge gain happened basically everything that was involved in this for loop, because every time we go through it, we've got to reference that variable, except for X, because X is only value. X isn't being reassessed every single time we go through this loop. How do I know that? Because we didn't get any gains by, not change. Like we only need to reference value of X once before we know, okay, how many loops or iterations are we going to do? We don't need to keep re-referencing what is X. That's not, that we don't have to do that. So anyway, okay. So that's one thing. Now, knowing what we know in this loop, so, maybe you want to impress all your friends who aren't Python programmers, and you want to say, this is why I use Python, and I know how to make Python so fast. So what's one way that we could make this better? Because a lot of times, maybe you've heard that Cython can help you be like 200 times faster, right? So what could we do? Well, we could just make that for loop larger. So like, what if we said, rather than 5, what if we said 5,000? We might have to change this number of iterations. Let's do 1,000. Save. We don't need to rebuild. We just test again. Boom! 119 times faster. 36. That's ugly. Let's go back to 118. Oh, 124. Okay, so we're pretty balling at this point. Let's try 50,000. Ugh, it's taking forever. Come on, you gotta be faster. Wow, I think we went down in speed. 140 times, we're going with that one. Okay, so we've written code that's 140 times faster. Anyway, okay, so there are at least a few examples, or at least one example of some simple code, but adding some simple typing information, which ones actually mattered, which ones really didn't matter. For example, two, let's get rid of the definition here. So let's just take away that entire, top line. Again, this shouldn't have really a huge effect. I hope I'm not wrong. But Python 3 testing.py. We left our loop gigantic, but anyway, cool. Yeah, so it doesn't have like a huge impact. And before like 36. Yep, cool. So that's not really essential that you give it this. The only time it would be essential, really, probably in my opinion, is if it needed to be a CDEF. But anyway, or if you're calling the function a whole bunch of times in a loop, make it CPDEF, give the return of it, and then give this a value. Okay, now let me go ahead and build that one more time. Let's test it, and I want to show one more thing before I let you all go, and that is the HTML kind of conversion that you can get from this. So so what I'd like to do is let's take I'm trying to decide how I want to do this, because we kind of, let's go example.py. So let's copy this, paste. So we're just pasting the original example.py into the new example sci.pyx. Kind of what we had initially. I saved it, and then now what I'm going to do is go into the terminal, and I am going to do, I think it's just Cython -a, and then let's call this, what was it, example? It's just example underscore sci. Example underscore sci.pyx. We'll run that, and what this does is it just creates your C file, and even though this is here, it doesn't create your SO file. I don't know why. I wish if it was a single file, you could just do Cython A rather than have the setup.py or some form of Cython. If somebody knows that you can do that without the setup.py, let me know, because it doesn't make any sense. Like, why wouldn't you just be able to build it with just the Cython call? But for whatever reason, you can't. But what I'm interested in is the HTML file it produces. So what we can do is we can open this in Firefox, and basically, as it tells you right here, the yellow lines hint at your Python interaction. Interestingly enough, y equals 0 apparently isn't super close. I think it's there. It's just the least interactive to Python. But anyway, you can see all of, how close are we in Python. So clearly the definition is just pure Python, and then the for loop is very heavy in Python. So now we can close this, and let's go back here. Let's just do Control Z, save, and then let's now do the same thing again. We'll get a new HTML file. Let's open that one. And now we get basically only one line. That's the first line, which is cpdef, because we wanted to be able to reference it and use it in Python. But other than that, the rest of this is nowhere near Python, right? So anyway, pretty cool. So what has it done for you? Basically, like, this for loop has been written for you in C. So that's in this file here. And I don't know about you, but I'm not going to write, like, especially if you have like a large Python program. I mean, it's going to generate, like, if you had, like, let's say 50 lines of Python, it's going to generate like hundreds of lines in C for you, which would be very annoying to write yourself, and I probably would not be successful. But obviously this is pretty successful. It's super tested. Like I said before, it's used in a lot of large libraries like NumPy, Pandas, and so on. It's a huge list of packages that use Cython. Okay, I think that we've made it through everything I wanted to cover at the most basic level. Hopefully that was simple enough. I personally was really surprised. I had looked into Cython quite a few times in the past, and I just kind of found the documentation to be not so great. I found a lot of kind of like tutorials on Cython, but it was really like talks on Cython without actually showing exactly the code. And so for the longest time, I just couldn't figure out Cython. But then when I figured it out and I realized, oh my gosh, it's basically, at least a beginner in Cython, all it is just typing information. That's it. There are more interesting things that you can do. Obviously, if you're a C programmer or C++, there's some other things you should look into. Also, we can't do it in this for loop, but there are certain things that we can add like with no GIL. So this will release the GIL for you, and then you can do things. Unfortunately, you're not going to be able to do this. You're not going to be able to modify this without the GIL. Obviously, you couldn't do that in C anyways. Like, you'd have to handle for that. But there's some things that you can do without the GIL, as long as they're not, changing some sort of shared variable or something like that. But yeah, there's quite a few other things that we can do with Cython, and I might cover them more in the future, but at even the most basic level, just adding typing information can give you huge improvements. So anyways, that's all for now. If you have questions, comments, concerns, something specific you'd like me to cover in Cython, feel free to let me know below. Otherwise, as always, thanks for watching, thanks for all the support and subscriptions, and I will see you in another video.